The chapter is Quadrilaterals for standard 9. This it's given ABCD is a trapezium and P, AC and BD are the diagonals of the trapezium, and P is the midpoint of AC and Q is the midpoint of BD is given. Now we have to prove PQ, that is the line joining the midpoints of the diagonals. PQ is parallel to AB and PQ is also equal to half of difference between the sides, that is AB minus CD. So first we will do the construction. Through P, draw a line DP which meets AB at R. So draw line DR through P. Now we will consider the two triangles APR and DPC. So triangle APR and triangle DPC. So we have AP is equal to PC. So AP is equal to PC. This side before that we'll write the angle. Now these two angles are equal because I'll put it as 1 and 2 because CD and AB are parallel. So alternate interior angles. We'll write that as the first criteria. So angle 2 is equal to angle 1. A, alternate interior angles. AB is parallel to CD. Now we have AP is equal to PC. Side P is the midpoint of AC. And then we have these two angles are equal, vertically opposite angles. So angle APR is equal to angle CPD. This A, vertically opposite angles. Therefore, ASA congruence, we can say triangle APR is congruent to APR. So CPD. ASA congruence. So we can write AR is equal to CD. So we get these two are equal, and we can also say PR is equal to PD. PR is equal to PD. CPCT. So these two are, so P is the midpoint of D. Now we know it is already given Q is the midpoint of this. So we will consider the triangle RDB. Consider triangle RDB. We can say PQ is equal to, PQ is parallel to RB and PQ is equal to half of RB. The reason is we have PR is equal to PD. This is 1. This is 1 we'll write, and this is 2. So PQ is equal to half of RB. The reason is P and Q are midpoints. Now we can write PQ is equal to half of RB. Instead of RB we can write it as half of RB can be written as AB minus AR. AB minus AR is equal to RB. Now we know AR is equal to CD from 1. So we will substitute that as AB minus CD. Reason, substituting AR is equal to CD from 1. So we got the result, PQ is equal to half of AB minus CD. Now we also got PQ is parallel to RB. So PQ is parallel to RB. That means PQ is parallel to AB and it is also parallel to CD. So in the figure, it's given AD is perpendicular to this line and BE is also perpendicular to this line and C is the midpoint of AB. So these two are equal. Now we have to prove CD equal to CE. So first we will draw a line. So these two are perpendicular, means so AD is perpendicular to BE. Then these two are AD is parallel to BE. Now we will draw another line through C which is parallel to AD. So construction. We'll draw CF parallel to AD. So this is CF. Now if you see, now all the three lines are parallel, so even this is equal to, so angle DFC. So proof. So we have AD perpendicular to L, BE perpendicular to L, and from this we get AD is parallel to BE. AD is parallel to BE. Now we have drawn CF parallel to AD. Therefore we can say even this is equal to 90 degrees. So therefore CF is also perpendicular to L, because CF is parallel to AD. So this is also 90. These are corresponding angles, or you can even say these are co-interior angles. So since this is 90, this is also 90. Now you got all the three lines are parallel. Therefore AD is parallel to CF is parallel to BE. Now we know it is given AC is equal to BC. Therefore DF is equal to FE. We know if A, L, M and N are parallel to each other and they cut equal intercepts between this transversal cuts equal intercepts, that is AB is equal to BC, then it will cut off equal intercepts on the line on the transversal Q also, that is DE is equal to EF. If AB is equal to BC, then DE is equal to EF. And L and M and L, M and N are parallel. L, M and N are parallel. If AB is equal to BC, then DE is equal to EF. So we are going to apply this here. So AC is equal to BC. Therefore we can say DF is equal to FE. So DF is equal to FE. The reason we can write it as the three parallel lines cut off equal intercepts on the transversals. Now we will consider, now DF is equal to FE. Now we have to prove DE is equal to CD is equal to CE. So we will consider these two triangles. Triangle CFD and triangle CFE. Now CFD, we can say angle F is equal to 90 and this is both are 90. Therefore, we can write angle CFD is equal to angle CFE, that is equal to 90 degrees. This is angle A. Now, FD is equal to FE. FE, that is side. This is right angle, side from 1. And then we have CF as common. Sorry, it is not RHS, it is SAS. We have to prove the hypotenuse. So we can write as FD is equal to FE, then angle 90, and then CF is equal to, CF is common. So we will write CF is equal to CF. It's common. That is side. Angle side. So SAS. So therefore you can say triangle CFD is congruent to triangle CFE. So from that we can write CD is equal to CE. This is SA's congruence. Here it is given ABCD is a parallelogram. Sorry, it's a trapezium where AB is parallel to CD. AB is parallel to CD and it is given P and Q are the midpoint. Q is the midpoint of BC. Q are midpoints of AD and Q is the midpoint of BC. These two are equal and these two are equal. Now we have to prove R is a midpoint of AC, that is AR is equal to RC, and also we have to prove PR is parallel to AB, and we also have to prove AR is equal to R is the midpoint of AC and PR is parallel to AB. So to start with, so to prove PR is parallel to AB, we have only P as the midpoint. We do not have any other. To use the midpoint theorem, we should have two criteria. Either two midpoints, then you can say that it is parallel to the third side, or we should have one midpoint and the line is parallel, then you can say the other is midpoint. But here we do not know whether PQ is parallel to AB, it's not given, and R is a midpoint, that is also not given. So we cannot use that. So we have these are parallel and these two sides are equal. So we will consider the triangle CDQ and BQE. These two triangles we will consider. So triangle CDQ and triangle BEQ. We can say these two angles are equal. These two angles are equal because these two are parallel, so alternate angles. And then we have these two sides equal and these are vertically opposite angles. So AAS, we can say the two triangles are AAS. So we'll start with angle 2 is equal to angle 1 is equal to angle 2 this is angle alternate interior angles CD is parallel to AE. Then we have 3 and 4. Angle 3 is equal to CDQ. So angle 4 is equal to angle 3. It is vertically opposite angles. And then we have CQ is equal to BQ. Its Q is the midpoint of BC. So we can say triangle CDQ is congruent to CDQ. So we can say it is BCD. So BEQ. Triangle BEQ. AAS congruence. From that we can say DQ is equal to EQ. DQ is equal to EQ. So DQ is equal to EQ means Q is the midpoint of DE by CPCT. Now we'll consider the triangle ADE. Triangle ADE. Now you have P as a midpoint, Q is the midpoint of ED. Earlier the Q was the midpoint of CB. Now to consider this triangle we need Q as the midpoint of DE. That's what we have proved. So therefore you can say PQ is parallel to AB. The reason is P and Q are midpoints. So from that you can say PR. So we can say PR is parallel to AB. So we have proved one thing. Now we have to prove R is the midpoint of AC. Now consider the triangle DAC. Now P is the midpoint. PR is parallel to, now we proved PR is parallel to AB, but AB is parallel to CD. Therefore PR is parallel to CD. So P is the midpoint and PR is parallel to CD. Therefore R is the midpoint of AC. So R is the midpoint of AC. The reason is P is the midpoint. Then PR is parallel to AB. AB is parallel to CD. So using midpoint theorem, R is the midpoint of AC. So we have proved the other criteria also.